2, 1, it's recording. Here we go. 6CD, this is cubics chapter. Chapter 6 is cubics. Cubics is x to the power 3. Okay, so you've done chapter 3, which is x to the power 2. What you had to learn with x to the power 2 was to learn to factorize it into 2 brackets. Now in x cubed, you have to learn to factorize it into 3. Okay, but the only way to get to 3 is you need to know how to do 2. That's why I said chapter 3 was important. Yeah? To get these 3, you need to first find the first one. The key theorem is called factor theorem. Now, if you don't understand what I just said, it's okay. Just follow the process. Okay? Here, this is a cubic equation. Our goal is to change this 1, 2, 3, 4 terms into 3 brackets. That's our goal. That's what we want. We want this. Okay? That's what we want to do. Problem is how? So the first technique is you need to first find, you need to first find the first bracket. You need to find one. There's no other better way besides trial and error. Okay? And this is how it works. The trial and error in factor theorem, the theory says this. Factor theorem says if you can sub in a number, whichever number, into this equation and it equals 0, it's a factor. Okay, in a nutshell. What I mean by that is something like, say, 12. What are factors of 12? Give me 2 numbers that multiply to give you 12. 3 and 4. See, 3 times 4. See how it's in 2 brackets? 3 times 4 gives you 12. That's a factor. 3 is a factor of 12. 4 is a factor of 12. If you divide 12 divided by 3, you get 0 remainder. That's what they're trying to do here. They're trying to say if you sub in a number and it equals 0, it means it's a factor because it has 0 remainder. That's what they're trying to say. So the question is, what number do you sub in to x to get 0? Now, factor theorem, the hint is you use the last number, 12. So let's break it apart. Factors of 12, we have 1, 2, 3, 4, 6, 12. These are the numbers you're going to test. Okay, now most likely in your test, in your SACs, in your exams, they're never going to give you 12. Because if you're going to sub 12 in, doing 12 cubed and then doing 12 squared, it takes too long unless you have a calculator, right? If they give it to you in a test and it's no CAS, it's very likely one of these first 3 most of the time, okay? If you have a CAS calculator, then it could be anything. You just got to sub them all in. Now remember, you don't just sub in the positive numbers, it could also be negative numbers. So you got to test 1, positive 1, negative 1, test positive 2, negative 2, test positive 3, negative 3, up until you get a 0. Doesn't matter which one. Just test. Okay, that's trial and error. There's no better way to do it. That's the only way to get the first factor. Okay, so here we go. I like to test with the smallest number first, so I'll do 1 and negative 1 first. Okay, so here we go. Write this in. X equals to positive 1. Let's sub it in. You get y is equal to 1 cubed plus 3 times 1 squared minus 4 times 1 minus 12. So I subbed 1 in. Logically, will that equal to 0? Well, let's see. That's going to be 1 plus 3 minus 4, take away 12. Will that equal to 0? No, you don't have to actually calculate it. You just need to look at it and say, does it? Will it? No. Negative 4, negative 12 is too big. Those are too small. It's not going to work. So move on. This doesn't work. X equals to negative 1 then. What if I switched it around? So if x equals negative 1, y now equals to negative 1 cubed plus 3 times negative 1 squared minus 4 times negative 1 minus 12. Same thing again. Let's go. It's negative 1. Negative 1 squared is positive. So positive 3. Negative 1 times negative 4. Positive 4. Oh, this is looking a bit closer. But 3 plus 4 is 7. And that's still negative 13. So 1 doesn't seem to work. But what we can see is this negative looks like it's a better contrast compared to a positive. Okay, so I might try negative 2 the next. Okay, so next one I try. Let's do it. I actually don't know which one is the actual factor, so we're going to have to keep testing. So here we go. Let's try negative 2. Y equals to negative 2 cubed plus 3 times negative 2 squared minus 4 times negative 2 minus 12. Here we go. Negative 2 cubed, negative 8 plus 12. That's good. And this is also plus 8. Oh, look at that. See my trial and error? But even though I trial and error, can you see how I got information from the first one and the second one? Why did I go with a negative? Because I saw this was a better outcome than that one. Yeah? So then I said, yeah, probably a negative answer. And then I trialed. So there's still a bit of work that you got to do, but that's the hardest bit. That was the hardest bit that you had to do. Find the first factor. So now, this actually equals to 0 because 8 take away 8 is 0. 12 take away 12 is also 0. What does this mean? X equals -2 is a factor. But remember, in null factor law, if x equals to -2, what should be in the brackets? X plus 2. Yeah? So for those who got confused about why it's x plus 2, do you remember back in year 10, if you were doing methods, if you had x minus 2 and x minus 3 in brackets, and they say solve for x, if that equals 0, you would say null factor law says x equals 2, x equals 3. So it's the opposite of what you see there. So if that's minus 2, that's plus 2. Yeah? So now, what have we done? We now know this massive equation here, this x cubed, I'm just going to write on the side so that you see the visualization, x cubed plus 3x squared minus 4x minus 12, that we now know one of the brackets is x plus 2. That's what we know. We're just missing this bit now. That was 6c. If you understood what I just said there, that's 6c. In essence, the theory of 6c is keep subbing the numbers in until you get 0. And they've designed the question so that it does work. One of them is going to equal to 0. You just don't know which one. Yeah? That's your first step. That's 6c. If you moved on from 6c, then 6c, next step is how do you get that quadratic bracket? Okay? So here we go. So we got the x plus 2 as a factor. How do we get the next two? There are 3 techniques. I'm going to do the first one. This is called polynomial division. So we now know if I take the whole number, divide by a factor, I should get the other factors. Why? It's the same idea as 12 divide by, if I know one of the factors is 3, 12 divided by 3 will give me the other factor. See, 12 divided by 3 will give me 4. So that's why here, if this is the whole number and you divide by a factor, you are going to get the other factors. That's why you divide them. But if you divide them, this is what it looks like. You're doing x cubed plus, what was it again? 3x squared minus 4x minus 12. And you're dividing this by x plus 2. What this means is how many of these x plus 2's fit into that expression? Here we go. Let's write it in. This is your long division. X plus 2. How many of those fit into? X cubed plus 3x squared minus 4x minus 12. So copy this bit down. So this is key for most students that I've realized they find long division very difficult. It's probably because back in primary school that was a bit more confusing and you're more used to short division. Yeah? This is how it works. You ask yourself, we're going to try to get the first term or every single term here. We're going to try to replicate it. We ask ourselves, what should I multiply to x to get x cubed? What do I multiply to x to get x cubed? X squared. So x squared multiplied to x will give me x cubed. I want these two to match. Okay? But the thing is, it wasn't just x, it was x plus 2. They come together. So if I times x squared to the x, I also have to multiply x squared to the 2 as well. If I do that, x squared times 2 fits in this column now. So all the x squares fall in this column. So then I have plus 2x squared. In long division, you multiply them and you find what's the remainder. Now this fits nicely. Remainder is when you subtract them. X cubed minus x cubed cancels out to be 0. But what's 3x squared minus 2x squared? What do you get left over? Natalie? Yeah. 3x squared minus 2x squared gives you x squared. So fill this in. So we're going to write now x squared is left over. We still have the next two terms to work out, so we drop them down. Here we go. Drop down then minus 4x. And then we start again. This is the algorithm for long division. Okay, let's do it again. Same thing. That's the term I want to match. What do I put up here to multiply to x to get to x squared? X. So here, I do the same thing again. I say it had to be a positive x, because x times the x gives me the x squared, but remember, it's not just x, it's x plus 2. So that's why I have to times x to the 2 as well. If I do that, this now, all the x columns comes here. So then it becomes now plus 2x. And your goal is to find the difference. You want to know the remainder. These two match, so it has to be 0. Always has to be 0. If it's not 0, you've done something wrong up here. So this one's 0 now. But then what's left? Be careful here. -4 subtract 2. -6. Very good. So be careful there. So -4 subtract 2. You now have -6x. And then the last step, drop in the -12. And you only got one more to do. One more to do. So same thing again. You need to match this -6x. What number do I put up here to times x to get to that last number? What must it be? -6. Very good. -6 times the x will give you my -6. Very good. So here we go. -6 times the x will give you my -6x. But then -6 times 2 gives me -12. And it's not by accident these two match. Because remember, it has to be a factor. And if it's a factor, it should end up being 0 remainder. So when I divide it, there should be no remainders left over. -6 minus a -6 is 0. -12 minus a -12 is 0. It makes sense. If you didn't get 0 here, you've done something wrong, either in the factor or in the algorithm. But it had to be 0. Sure? Okay? That's the minimum requirement in terms of what you need to do. Now, do most students get this? No. It takes a while. It takes a bit of practice to get used to the algorithm. So copy that algorithm just to get used to it. But what was the purpose of doing it? You found the remaining factor. So that means what you just figured out here, instead of this cubic polynomial expression, you worked out the factor through factor theorem. You now know x squared plus x minus 6. Why did you need chapter 3? Because you have to know how to factorize that. I assume at this point, most of you should be able to do that. So this one's x plus 2. What's the next one?
3 and 2. Negative what? 2 and
-2. And +3. Let's see. X times x is x squared. True. That gives you +3 minus the 2. Yes, that's correct. And then 3 times -2 is -6. Very good. So that's the only bit that was chapter 3. And that's what I'm saying. If your chapter 3 quadratics was not strong, you get stumped here. They all follow. And then cubics will follow for the next few chapters. Yeah. So that's why you needed to know the basics. So that's a bare minimum. Obviously, then the next exercise 6D will say solve for x. If this was equal to 0, well, x equals to now -2, -3, or 2. And that's just the next exercise. But that's what I'm saying. You get blocked out. If you can't factorize, you can't find the x-intercepts. If you can't find x-intercepts, you can't sketch. If you can't sketch, you can't analyze. And it just follows on every exercise. So your core, I'd say don't rush. Learn these skills. Learn how to do just the factorizing bit. That's the biggest skill that you can take out of chapter 6. Make sense? So take your time, learn the polynomial division, or here's the next two. If you looked at this and you checked out, you're like, oh my God, there he goes again with his algebra. It's okay. There is 2 more techniques. This one I do like. There's a bit of intuition. So if you're a bit more of an intuition person and you like less working out, third one's good. Second one works, but know that there's a limitation. Once you learn this one, you probably prefer this one more than the first one, but it doesn't always work. Okay, so here. This is how the second one works. I'll show you how quick it is. So, this was our equation. We had x cubed plus 3x squared minus 4x minus 12, yeah? Synthetic division is the same thing as long division, but they remove all the junk. Have you noticed that in our technique, wasn't it redundant that it's always 0, 0, 0? So that's why they're like, wait a minute, why don't we just focus on these ones? Those are the key ones. Yeah, so these are the key ones. So what they do instead, they said, all right, let's forget about the x's, boys. Thanks. Synthetic division works this way. I'll do it in blue so it looks different. Write down the coefficients, meaning just the numbers in front of the letters. So for the first one, x cubed, coefficient is 1. Right, 1. Next one is 3. Right, 3. Next one is negative 4. Next one's negative 12. Right? The one on the outside, remember yours was x plus 2 as a factor, but we know it's x equals negative 2. So you put in the actual number, x equals negative 2. So negative 2 at the front. So here, this is negative 2. So you remove all the junk, all the x's are gone, and you only focus on what's going to be key, and this is what they do. Here's the pattern. Drop the first one. So the first one comes down. I used to say it to my year 11s back like 10 years ago. I used to say drop and pop. Okay, so what I mean by drop, and then you pop it over here. But to pop it over there, you have to do negative 2 times 1. Negative 2 times 1 is? Negative 2. So you drop, you pop. The next thing, you drop again. What's 3 take away 2? 1. So you drop. After you drop, you pop. But to pop, you have to times. Negative 2 times 1 again. Negative 2. Then you drop again. Negative 4 times negative 2. What?
Negative 6.
Negative 6. Negative 4 take away negative 2. Take away 2. No, I didn't say time. I said drop and you do pop. So negative 2 times 1. Negative 2 times that, yeah? So you pop. And this is now negative 6. Do the same thing again. Drop. So you dropped. Now to pop, you always have to times the outside number. Okay, so I dropped the 1 times by negative 2, I've dropped to here. Then when I dropped it down, I do 3 minus 2 is 1. I times negative 2 to 1, pop it over here. Negative 4 take away 2 is negative 6. Negative 2 times negative 6 gives me. But then if you did negative 12, oh sorry, positive 12. Thank you. Negative 12 plus 12 is 0. What do these numbers represent? That's your quadratic. That's the last remainder. So this is 1x squared plus 1x minus 6. That's what that represents. And if you actually look, have you noticed the ones I highlighted? That 1 was the 1. That 1 is that 1 there. And that negative 6 is this negative 6. That 0 is this 0. Because all they're focusing on is they removed all the junk and they just focused on the coefficients that actually mattered. You don't have to understand the process, like why it works. You can just follow. So drop and pop. Yeah? Remember, I know a lot of students will like this method. It's cleaner, but there is a limitation. You can't use this method if it's not x. If this was 2x plus 2, it won't work. If this was 3x plus 2, it won't work. It only works when that's a 1. But I even found a technique to even combat that. If it was a 2, the final answer times it by half. If it was a 3, final answer times by a third. But I didn't want to teach my year 11s back then why that works. It was just too confusing. So then I just taught them to do this and number 3. But I do know a lot of YouTube videos and teachers out there, they teach this way. But there is a caveat. It doesn't always work if the number in front of x is not 1. If the number in front of x is 2, 3, then you have to alter your final answers. You have to times them all by half or times them all by a third. Makes it a bit trickier, yeah, if you don't remember the process. Cool? All right. Last one. Let's say you still found this one too confusing and you prefer a one-liner technique rather than this one. Here's your last one. Inspection method. So you found out it was x plus 2 as a factor, right? You know this needs to be a quadratic. Now, there's a bit of intuition, so I'm going to write the actual equation again so that you can see. There's 2 ways to do this inspection too. So I'll show you the one that I usually do, but I mean, you could do it any other way you want. So x cubed plus 3x squared minus 4x minus 12. Okay. Inspection method means you're going to look at this and you're going to try in your head to match those numbers. That's how it works. First one. X has to multiply to something to get to x cubed. Logically, what should that number be? X squared. So we already got the first bit. It clearly has to be 1x squared times x will get you this one. True? But remember, because it's coming in twos, you also have to multiply the 1x squared to the 2. So in your head, or if you like, you can write on the side, you can also say, so you have to also times the 2 to the x squared. So in your head, just keep in mind you've got a 2. Now you look at the x squared here. See how that's also an x squared, but what number is this one? It's a 3. That's a 2. So what am I missing? Another 1. So I need a 1x squared. So to get a 1x squared, I need an x. Why an x? Because again, you're going to do x times x. You're going to still get that x squared. So, but I know it had to be 1 because x times 1x will give you that extra 1x squared that you were looking for. Get me? So the logic is you put in 1, then you ask yourself, okay, I did that is 1, but don't forget, you still had that 2. So we're going to do it again. Let's keep another number in our head. 2 times 1 is 2x. But then, let's look at the x's again. If this is a 2x and this is a negative 4x, they're different. How do I go from a 2 to a negative 4? Minus 6. So the number here has to be minus 6. And look at that. We're done. That's the actual answer. That's what we got up here. Now that's called inspection method. It gets a lot harder when you have fractions and all that, but just as a simple one from your exercise, I'm pretty sure inspection method will work. You just have to keep hold of that number. So if you just think about what I did before, how do you get the first? Make sure to times the 2. How do you get the 3? Add on the number, times the 2. How do you get that number? And you get your last number. It's very intuitive, right? So my year 12s, I only had 2 students in the SAC who used this technique. Most students use polynomial division and some use synthetic. Okay, so this one I find that more special students often use it because their intuition is strong. Don't have to, because it means that when you do get a complicated one, there always has to be something you can refer back to. So I recommend generally learning this as a core, but if it's really too hard for you to remember, you got these 2. Cool? Okay, so what I'm going to do now, so I've been talking for quite a bit. I'm going to pause the video. I gave you another 2 examples there. And you pick whatever method you want out of those 3. Have a go. And then every 5 to 6 minutes, I'm going to show you my answer up on the board. See if you got the answer. You can check on your calculators too. But I'm hoping to give you some edge for 6C and 6D. Okay, so 6C and 6D is just 2 things. Factor theorem and then how to factorize it. You're just going to learn those 2 skills. Yeah?
You can stop the video.
Yeah. I'll stop the video.